Okay, so this next video is on angular velocity. We will go over this in class, but not to this level of detail, and this is also something that you can come back to. So first we want to define theta. So we're going to look at a circle. We'd have a radius of the circle, and if we looked at maybe creating an angle, theta, we'd have an arc length right here that we'll define as s, and we're just going to have our angle is going to be equal to s over r. So we're used to having things in degrees, but by looking at this ratio of the arc length as compared to r, we're actually dealing with radians. That is to say, if we were to go once around the circle, one revolution, the arc length would be 2 pi r, and the radius is r. So therefore, this is just equal to 2 pi. And the ratio pi actually comes from, instead of radius, you're looking at the diameter as compared to the arc length. Or, I'm sorry, I should flip that around. The arc length as compared to the diameter is equal to pi. That's where that ratio comes from. Pi is a ratio. All right, so now that we have that defined, let's talk about the speed as you travel in a circular path. So as you go around in a circular path, let's give some object here. Just put it as a dot. We have some speed that we're traveling, v. Okay, so let's say that we're going to look at, I don't know, let's pick one revolution. If we're looking at one revolution, we're going to say that time for one revolution is equal to a period, which we're going to give the symbol capital T instead of lowercase t. So, of course, you guys all remember that the velocity is the change in distance over the change in time. So we're talking about one revolution. One revolution is all the way around. That's 2 pi r. And the time now for that one revolution is t. So that would be for this velocity here. But now, what if we have, let's say, like a record player or something like that going in a circle. So as this record player goes in a circle, any point along this line that I've drawn here is going to have the same period, but the velocities are going to be very different because they're traveling, let's say, at an inner radius, traveling a shorter distance over the same amount of time. So that takes one revolution, one period. Everything along this line, along this radius, is going to have the same period. But because they are traveling different distances based on the radius, they're going to have different speeds. So what we're looking at here is a speed. So we want to think about this in terms of, or it's helpful to think about this sometimes in terms of the amount of time it takes to go all the way around, or the amount of time it takes to go like 360 degrees, or the amount of time it takes to go 30 degrees, the amount of time it takes to go 40 degrees. And we're already kind of familiar with this because we know RPMs, revolutions per minute. So a typical record player might have 33 revolutions per minute. And so that is 33 revolutions per minute. And you could easily figure out how many revolutions there are per second by just converting your minutes. Obviously 60 seconds per minute, so you just divide this by 60 to figure out how many revolutions per second. And since we're dealing mostly with seconds, that's what we would convert this to if we were dealing with some sort of problem like this. We wouldn't be leaving it minutes, even though RPMs is a typical value or quantity that is given. So what we're talking about when we're talking about revolutions per minute is we're talking about an angular velocity. Angular velocity, we're going to give the symbol omega. just a curly W, I guess you could call it. And this is, as we described with revolutions per minute, that's the revolutions over a certain amount of time. Or, instead of dealing with a full revolution, you could deal with just a certain angle. So, a change in angle over an amount of time. That is to say, if we have some circle, and now we have this moving, give it an omega, and it moves a certain distance up here, so that the change in the angle, right? And it's taken a certain amount of time to get there. That's how fast this is moving. Okay.